Okay, you may recall this integral. It was a while back, and it's a tough integral, I know that. And we tried to use U substitution to do it, but we got into a loop. And I did use Sage, and I found out using Sage that this integral produced this number over here, approximately this number over here. If you want to revisit that problem, it's on page 11. I'm sorry, it's problem 11 on page 72. It's way back in the beginning of the course, all right? So at that point in time, what I said to you that you'd benefit by knowing the series expansion to accomplish a task. Before I do that, though, I want to point out there's pretty famous problems in mathematics, and one of the famous problems is this one over here. And a lot of people try to figure this one out, and we're trying to figure out this sum over here. By the way, it has something to do with the original integration. And Euler did this in 1734. He showed it was equal to this over here, right? Now we're going to use this fact. Now a lot of people try to figure this problem out. I think they were, I'm going to say probably spending about 100 years to do so, but Euler came up with an elegant reason why that was equal to pi squared over 6, all right? So what I want to do is I want to go through the technique that to solve this integration. And the first thing to do is recognize that you need a series, all right? So what I'm going to do over here, I'm going to start to erase, and I'm going to write down the series I want to obtain. And someone says, well, could you memorize this? Yeah, you could, but like a lot of things in life, I don't want to memorize something. I want to look at this, and the way I'm going to look at this over here, I look at something I do know, and I know this over here. I'll write this down for you. I know that 1 over 1 minus x is equal to 1 plus x squared plus yada, yada, yada. And this is valid for x's that are certainly between those two numbers over there. All right, it's valid for that. All right, it's valid. Now what I'm going to do, I'm going to integrate both sides. And if you integrate both sides here, let me write that down for you. You get this over here. And you're going to integrate the other side. And that's not so bad. For example, the left side is just a natural log of 1 minus x. Now, certainly when you differentiate that, you'll get 1 over 1 minus x, but you get a minus sign, so you've got to take care of that. I'm going to put a constant integration over here, c. And if you integrate the right-hand side, what do you get? Well, you get x plus x squared over 2. Well, let me make this over 1 then, plus x cubed over 3 plus yada, yada, yada. There's also a constant integration over there. And I'm just going to integrate it. I'm going to integrate that into the c over here. I'll say there's some constant over here. Whoops, let me get my red pen out again. So again, there was a c over here. I just pulled it over here, all right? So I'm going to pick a number. Again, kind of tricky, but I'm going to pick the number to be, let's see, x equals 0. And what you get over there, you would get, and again, you could do that by a limit too, by the way. You get the natural log of 1 plus c, I don't know what that is yet, is equal to a bunch of zeros, so I'll just say 0. What's natural log of 1? It's 0, so c is 0. So I got my series. I got this over here, the natural log of 1 minus x, or I'm sorry, the opposite of that would be the sum. Let's take a look at this. N equals 1 to infinity, x to the n over n. All right, let me outline that, show you where it is. And that's right over here. All right, and multiply both sides by minus 1. All right, let me get my eraser out. Let me erase all this business over here. And again, we're just working through the key as if I were studying someone's work. All right? And then what I did was I took this, I rewrote the integral. This is the integral again. And in place of, let me show you this. In place of this, I insert this. All right, let me show you that. So you'd have 0 to 1, natural log of x, and then it'd be times this crazy looking sum here. Okay, so I see that. I notice I factor out a minus 1 over here, and I'm seeing this part over here now. All right? Now, before I do anything on it, sort of like this looks really strange. It really does. So I want to point out, if I were to just expand that a little bit, I might be able to figure out a simpler way of writing that down. So if you were to write that down, it's 0 to 1, the natural log of x times, well, let's write this down. It's going to be x over 1 first power, x over 2 second power, x to the second power over 2, plus x cubed over, 3 plus yada, 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 dx. And I realize it's just a sum of a bunch of integrals, right? Like the first integral would be the natural log of x times x. The next integral would be, the natural log of x times x squared over 2. So what I do is I wrote it down as a sum instead, all right? A sum of integrations. And that would be the sum. Let's write this over here carefully. N equals 1 off to infinity of an integration that looks like this over here. 0, 1, natural log of x times x to the n over n dx. All right? I'm kind of looking at that, and I realize that I could probably pull the n out because it has really nothing to do with the x's. So I write this thing as, let's write this careful down. It's n equals 1 to infinity, 1 over n, limit of integration here is 0 to 1, natural log of x. Let's take a look. Times, let me put this in parentheses, times x to the n dx. All right? So I want to point out, this is going to be a tough, whoops, I didn't mean to do that again. This sum here needs to be done now. All right? That means I got to do the integration, all kinds of work over there. Let me show where that's written. That's written right over here. We're going to do that sum. Before I do that, I got to remove that integration symbol though, and that's going to be some work. All right, let's go through that. And I'm pretty comfortable that I'm at a particular place, and I want to point out what I want to do now. I want to do this. I want to do that integration. All right, let's go to the next page, and we're going to attempt to do that integration. And the way to do that, I'm going to say, basically, it looks like I could do that by integration by parts. All right, so let me write down what I believe are good parts. So I'm going to say u is equal to whoops, sorry about that. I'm going to say u is equal to, let's write this over here. U is equal to the natural log of x, and du would equal 1 over x dx. And I'm going to say this is the u part, and this part over here is the dv part. Let's write that down. So the dv is going to equal x to the n dx. I can integrate that. I'm not going to worry about the constant until the end of the problem, by the way. Actually, it's a definite integral. I don't have to worry about the constant. It's going to disappear. What do you have here? You get v x to the n plus 1 over n plus 1. All right, let's go back over here. I want to show you where this stuff is written down. This is written here. Okay? And we're going to just do the integration now. And what do you get over there? Let's write this down. So it's going to be x to the n times the natural log of x dx. Again, this is my dv, and this is my u. So what do you do? uv. So let's take a look at that. uv. So it's going to be x to the n plus 1 over n plus 1 times the natural log of x. Let's put the limits of integration in over here. So it's going to evaluate from 0 to 1. It is a limit problem, and I'm not writing it down. And then what do you get? Minus, let's take a look at that one. 0 to 1. Now what I put down? I have to put down the VDU. And let me just do that over here. So I need to put the VDU down. And what would that be? And I'll erase this and put it in later. So the V is what? X to the n plus 1 over n plus 1 times the du, which is 1 over x dx. Well, this simplifies pretty nicely to x to the n over n plus 1 dx. Let me write that down for you. X to the n over n plus 1 dx. All right, let me get my eraser out. And I think I'm ready to do that integration. Looks really easy. Couldn't have gotten easier there. And let's write this down now. And I'll do it. What do you get over there? Let's write it down. This guy turns out to be x to the n plus 1 over n plus 1 natural log of x minus, well, that's going to be what? X to the n plus 1 over n plus 1 squared, limit integration 0 to 1. All right, let me show you where this is written. And it's written over here. So this is written here. I got the C in there, but anyway, we'll take care of that because definite integration. Now what I'm going to do is I'm going to actually do the limit over here. And yes, it's going to involve a limit problem, and it does. So let's put this out of here. This is the painful part. We got to plug it in now, don't we? So let's plug in the 1 first. All right. And if you plug in the 1 first, you know, the upper limit, I'll write that down for you. So I'm gonna do this over here. So I'm gonna do the upper limit minus the lower limit. And the upper limit is when you evaluate this at 1. And what's nice about this, the first term would be 0, right? If I plug in 1 there, because the natural log of 1 is 0. Minus, you would get, just 1 over n plus 1 squared. All right, now let's do the lower limit, and that's more difficult. Now, the lower limit, this second term disappears, but I'm left with a limit problem now. And I'll write this down for you. I'm left with the limit as x approaches 0 from the right side of, well, let's be careful about this, it's going to be x to the n plus 1 over n plus 1 times the natural log of x. All right, so I think I can do that. And what would you get over there? Well, again, I'm going to try to write this down carefully. Minus 1 over n plus 1 squared. Let's see, minus that second limit, yeah? Wow, that looks tough. Let's write that down, by the way. I'm going to put it on the side, by the way. And I'm going to just write that down. The limit as x approaches 0 from the right. This looks like L'Hopital, by the way. I'm going to write it a little bit differently. I'm going to write it as, and I'm just looking at the x. It had nothing to do with the n. So I can write this as x to the minus n minus 1. I can write down the natural log of x there. All right? And so why would you do that? I think it might be easier for me to deal with that. So the top is going towards, well, that's minus infinity, right? And the bottom, right, that's also going to go towards an infinity, all right? So I got L'Hopital's rule. Let me write that down now. And I hope it's going to be easy to do. Let's take a look at that. And what do you get over there? I'm sorry about that. Keep doing that, don't I? Limit. I'm going to use L'Hopital's rule. X goes to 0 from the right. Let's see, the derivative of the top is 1 over x. The derivative of the bottom is what going to be? Minus n minus 1 x to the minus n minus 2. I got to rewrite that. Limit x goes to 0 from the right. And really nothing to do with the n's in the problem. What I mean by that, this over here, nothing to do with this over here. It's those x's. I'm going to be careful about this. So what do you get on top? You have x to the minus 1. And we're going to subtract away, let's see, the minus n minus 2, so plus n. And then you're going to get plus 2. What's that going to give you? N to the, x to the n plus 1. Well, that doesn't look too bad. Over, let's see, minus 1 minus n. And as x goes to 0, that goes to 0. Well, that's good. That disappeared. All right? That's a good news for me. So there's really nothing over there. It just disappeared. So what am I left with at the limit? I'm left with something pretty simple. I'm just left with, let's write this down for you. I'm just left with this. Now, don't lose sight of what we just did, by the way. I want to point out the only thing that we did was we did this thing. That's all we did. Now what I got to do, I got to put that in there. Now there is a minus sign on the outside, So what I'm going to do is I'm going to take this minus sign, pull on the outside, get positive then. And what he left off with? He left off with 1 over n times this thing over here, which would give you this. All right, so now I'm in another problem. I got to take that sum, and that's not an easy sum to do. All right, so let's write this down, and I'm going to start to erase things. And again, I'm at a milestone now, and the milestone I'm at is right over here. And the way I'm going to suggest you do this is by using partial fractions. Right, the telescoping, hopefully it's going to be telescoping, right? So let's write this over here. So 1 over n plus 1 squared would be equal to a over n plus b over n plus 1 plus c over n plus 1 squared. Multiply both sides by the LCD, you would get 1a n plus 1 squared plus b n plus 1 plus c times n. I would probably, just to do the problem over here, pick n to be 0 to make it easy for me to deal with this. And if n is equal to 0, I would just get 1 is equal to a. All right, so I know what a is. I'm gonna get this erased here. Whoops, that's a pretty big eraser now. I get a small eraser. And let me write that down for you. So it's going to be 1 over n. Now I'm going to pick n to be minus 1. And what would that give you? And again, we're plugging it in here. And I want to see what that gives me. Let's see, you would just get 1 equals minus c. So I know c is minus 1 now. I'm going to get my eraser out, and I'm going to erase that and put the minus 1 down instead. All right, things are working out pretty nicely. Now I'm going to pick n to be 1. What does that give me? 1. Let's be careful here. If n is 1, 1 plus 1 is 2. 2 squared is 4. So I get 4a. And again, a is 1, so I get 4. Plus, again, if n is 1, I would get b times 2, or 2b. Plus, well, not plus, because c is minus 1, right? So what's that going to be? Be careful here. I got to make sure I'm doing that right. 1 plus 1 is 2. 2 squared is 4. So you get 4a, so that's 4. Then you get b, again, n is 1, so you get 2b. And then you're going to get what for c? You're going to get, that would be what? Minus 1. Let's keep looking at that. I'm going to get the b now. So what do you get? You can get 1 equals 3 plus 2b. Take away 3 from both sides. You get minus 2 equals 2b. Ooh, b's minus 1. Isn't that convenient? Let's write that down now. So the b is going to be minus 1. All right, I'm going to get my eraser out, and I got to deal with that. All right, so I want to point out the way we've done that in the past is we've taken partial sums and try to predict what it's going to look like. All right, I got to make my eraser a little bit bigger this time. Much bigger. Again, I just want to get a feel for it. And let's write this down. So really what I'm looking at is like sort of like a partial sum. And the partial sum is going to be n equals 1 up to big N of this crazy looking thing over here. And what are you going to get? Well, let's write this down carefully. I guess I'll put it over, I don't know, got to put something down, right? So let's write this down. And this would be, 1 over 1, 1 over 2, yada, yada, yada. You'd eventually get to plus 1 over big N. Over here, what would you get? You get minus, second term in, 1 over 2, minus 1 over 3, yada, 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 all the way down to 1 over n plus 1. And then over here, you get minus 1 over 3 squared minus 1 over 4 squared, yada, yada, yada. Eventually you're going to get minus 1 over. You know what? I made a mistake, and I have to correct that now. So this guy over here, let's just correct that now. It's minus. All right? I'll make a correction there. And it's going to be minus 1 over n plus 1 squared. All right? So one thing I noticed about it immediately is I got some cancellations over here. And this would cancel off, this would cancel off here, so forth and so on. And what would you get there? You'd get this over here if you did this. You'd get, 1, and then you get minus 1 over n plus 1. And then you get minus, oh boy, this is going to be crazy looking, right? So it's going to be what? 1 over, I made a mistake, another mistake. I have to correct it. That's not 3. That was just wishful thinking over there. That was 1 over 2 squared. Get my eraser out again. That was 3 squared. So I'd get, 1 over 2 squared minus 1 over 3 squared plus yada, yada, yada plus 1 over n plus 1 squared. All right? So if you took the limit as goes to infinity, I hope you realize that this would just be the number 1 over here. And this would be that crazy looking sum. All right? So I write that down. And I'll tell you where that is. All right? So I'm looking at a limit now as the big N goes to infinity. And again, this would disappear. All right? This guy's crazy looking now. So I write it down. So what do you get? You would get, let's be careful about this. You would get 1 minus this business over here. All right? Now what I did over there is this is sort of like what we talked about in the beginning over here. And we know what this is, or at least part of that. We know if we put an extra term in there, for example, the 1 over 1 squared. Let me outline that for you here. So I insert that. Well, gee, if I put a 1 there, I'm really subtracting a 1, so I got to add a 1. If I add a 1, it's 2 then, right? And then I get this whole sum over here, which brings me back to the beginning of the problem. I know it's been a long time ago, this sum over here. And Euler showed that was pi squared over 6. So now we're at the stage where we could actually evaluate the integral, which is going to be 2 minus pi squared over 6. And we're done. Thank you.